Hello, this is Tom from Berlin's Space Technology TV, and today we are again with our resident genius Matthias, our CTO, and today we talk about quality assurance at BST.
Yes.
So now that the reaction wheels are running in the test, we're going to have a look at the general quality assurance procedures at BST, and as you explained, everything is automatic, and so that helps us with a modest team of engineers to achieve actually very high quality assurance. And maybe you can explain what we see here and how we normally would do the quality assurance.
Yeah, so not only the test report creation is important, but also, of course, to log every event that happen to the device, like tests or assembly steps or whatever, shipping actions. And and we use for that a tool named Gitlab, which is actually a versioning tool used mainly in software. But we are using it also in principle for our lifebooks, so to speak. We're using the ticket system of Gitlab to create decent lifebooks. And that's actually what one can see here. It's a different reaction wheel device, and you see there's a lot of issues, a lot of events logged here that happen to the device. It's quite nice searchable, and you have the complete history of the device, which is very important. And within each event, then of course you see the actual test. That is what we saw before, the testing of the test reports and stuff like this.
Matthias, can you show us a bit more how that would be applied in the electronic department, so electronic development?
Exactly. So in the electronic development, we develop here a lot of PCBs in-house, and of course we need to version these PCB developments, document them, and this is a typical repository here of a board, of a PCU upper board. You see a lot of description, block diagrams, everything is in the repository. And of course also the classical development steps. If you look to the commits, you see automatically what person has done what changes on the board itself. So that's also very important if you have multiple persons working on one board or one piece of software.
And you said that was originally coming from software. So typically the software guys were doing that, and then I understand that we learned that it's not only good for software, but we actually now use it in every department. Is that correct?
Exactly. So we in principle saw how good it works for software and also for the PCBs. We also said why not also include the mechanical development, so the development of housing, of parts.
Can you show an example of such things, so either mechanical or the incident stuff?
Here is so in principle, wheel drive electronic with a known bug that was actually sorted out was nevertheless coded and baked out, so it created a work that was unnecessary. And of course we then create kind of incident issues to find out why it happened. Is this a procedure problem? Was it just a human error?
What I find very interesting is the ability to track and to trace. So what I've understood is that we actually have the ability to trace all of our components, all of the subunits that we are producing, and all of the then engineering models, flight models, and whatsoever from beginning to end.
Yeah, so I can show. Let's stick to our reaction wheel example. Yeah, this is a ticket for a TVAC test, but the repository itself for the reaction wheel has a nice overview README with all the main interfaces described, but also what Tom mentioned now, a serial number overview. So each device here is logged, gets a defined serial number, a defined label, so that you can find the issues within Gitlab. But also, as said before, we are also logging which subcomponents, which motors, which gyros are built into a specific unit. They all get the same, their own serial numbers, and everything is logged here. And yeah, nicely accessible. You have links all over that show you immediately the complete lifebook of the device, and it's quite handy and fast in the end.
An important step at the production of components and subsystems is the assembly. of these devices. And here we have a look at the assembly instruction for one of our reaction wheels, and it's fully stored in our Gitlab. And Matthias, maybe you can say a few things about how that helps to produce these devices.
Yeah, we use also Gitlab to log our assembly procedures. The nice thing is that you can use templates, so whenever you create a new issue or want to log a new assembly campaign, you can work from a template that exactly tells you what steps to do. And then you can, in principle, after each step done, you can mark them as done, and and you have the complete log. And furthermore, what's also good is you can include images and instructions in it, so you know exactly how to build it if a different mechanical engineer needs to take over, or the last assembly was a year ago or something. So it's quite handy and serves us very well.
Okay, so that as you explained, that helps with when other people are taking over and building these things. By the way, what are these images that are popping up all the time?
Yeah, this is the still running reaction wheel test that we started half an hour ago. And yeah, so the test is still running, and the images are popping up to print and log the data in the automatic test report we talked about.
Okay, very good. So basically, these file logs basically give not only an instruction what to do, but a specific instruction also how to document it and which step to take. And as I understood, we always had the rule at BST: if there's no picture of a process done, then this has not happened. And of course, in the past, we only had like millions of pictures, but Gitlab as I understood, has helped us to very much structure this approach and make it much more repeatable and increase our quality assurance.
Exactly. So even there's of course still assembly steps. I have to take a lot of images. They are stored then on a file server of BST, but always the location and an overview is linked into Gitlab, so that always Gitlab is our main entrance. But yeah, that's how we work.
Thanks. Okay, gibt's